So circular motion at level 2, we're going to study objects that are moving in circles. The thing that we can assume about how they're moving in those circles at level 2 is that they move at constant speed. So velocity is constant. What does that mean about how we can calculate velocity if velocity is constant?
You can use the devil's work.
That made you so happy to say that, didn't it?
Keep that in the video.
We can use velocity as distance over time, and distance is just something's moving in a circle, distance is the
Circumference.
and so we rewrite this equation as speed is 2 pi r over t. What's the difference between little t, big T?
T is period.
T is period, and period means the amount of time it takes for something to repeat itself. And so the amount of time it takes for the thing to go around the circle once is the T. That equation, I'm not boxing it up because it's not on your formula sheet. Imagine we are talking about an object there that is going around the circle that way. What can you tell me about its velocity at that instant there, where it's drawn?
It's not moving.
It is moving.
Ah.
What direction is it moving?
Anti-clockwise.
Left.
Yeah, left for me.
But if you look at it
So
upside
we're
down,
not
it's
wrong,
not
but
moving
also
left
not
anymore.
right.
What I was hoping to hear is that its velocity skims across the edge of the circle there. What do we call that
It's
line?
a tangent.
It's a tangent, and so we call it the tangential velocity.
This is disgusting.
It sounds like some kind of disgusting fruit.
The complicated and counterintuitive thing about circular motion is that even though it's moving at constant velocity, even though it's moving at constant speed, it is accelerating. How can it be that it's moving at constant speed and it's accelerating? How can that be?
That literally makes no sense.
Going in a circle.
Why does
You know.
the fact that it's moving in a circle mean that it's accelerating?
Because it's also connected on the side.
How can it be accelerating if the speed is constant? How can that be?
Because it's moving down, maybe?
Because it's something to do with the tangent.
Something to do with the tangent thing. So what about if we then thought about our object once it gets over to there? Where's its velocity now?
Different.
Where? How do we draw the velocity? Tangent to the circle. So it's the same length arrow because it's the same size velocity. What's changed about the velocity? The direction. It's a vector, so it's got magnitude and direction. And so the acceleration in circular motion causes a change in the direction of the velocity, but not the size of it. So we've got constant speed, constant magnitude of the velocity. It's moving at the same speed, but because the direction it's pointing is changing, the velocity is not the same. That velocity's changed from pointing that way to pointing that way. That means there must be acceleration. The word we use for the acceleration in circular motion is centripetal.
Oh no, that sounds disgusting.
Centripetal acceleration, and the equation that is on your formula sheet for that is acceleration centripetal is v squared over r. Much more commonly you're going to see that written as an equation for force, centripetal force, centripetal force, Fc is m v squared over r. That makes sense because force is mass times acceleration. If the acceleration is v squared over r, to make that into a force, we just have to multiply by mass. That makes sense. We're happy with that. Centripetal means centre seeking. So the force is centre seeking. That acceleration vector and also a force vector is always going to point at the centre of the circle that you're moving around. To move around a circle, you have to be pushed into the centre of the circle. This vector, for velocity, to make it change from facing upwards to facing acrosswards, we had to pull it towards the centre of the circle. This is really counterintuitive. It seems obvious when I'm explaining it, but now you're going to think about yourself playing corners in a car. You go around and someone turns the steering wheel and there's 7 of you in the back seat, and which one gets crushed?
That's a lot.
The one in the
I feel
middle.
like that's illegal.
The one on the outside gets crushed. How can that be? If you're being pushed inward, how come the one on the outside gets crushed? What is going on?
Does it something to do with tangential velocity?
Is that centrifugal?
Is it centrifugal?
Don't ever say centrifugal force.
Oh, okay.
Why?
The one on the outside gets
Why?
crushed because you want to continue in the same direction as you were heading before.
Super force.
Zero force does not exist. Why?
Because if you're in a helicopter and you're hovering over the car and you observe what the car, so when you are inside the car, when your reference frame is the back seat of the car, you feel as though you're being forced to the outside of the corner. But as soon as you come outside of the car and look down on what is happening, you can see that the thing that's pushing the people inside the car around the corner, it's the outside of the car that's stopping them from going in a straight line. It's the tyres gripping the road that stops the car from going in a straight line and pushes it inwards around the corner. So it's
So it's not people that are moving, it's the car that's moving.
it's the car that is exerting a force on the people
Because
to
the people would
push
just
them
want to continue going in the same direction.
in a
The
straight
people
line.
wanna go straight.
Newton's first law. So in the absence of the centripetal force, like if you're going around a corner and you hit an oily patch, which side of the road, where do you go? What happens if you hit an oily patch and you lose friction, you lose the centripetal force, and you're going around a corner?
Out!
Out? What pushes you out? Don't say the centrifugal force.
I think it's a centrifugal force.
Centipede acceleration.
What happens if you're going around a corner?
Oh, you go straight.
Hit a patch of oil.
You just
You go in a straight line and a tangent to the circular path that you are following. So if at any point that centripetal force is removed, that means you then just travel at a tangent to that circle, following the path that you were following before. That is Newton's first law. An object in motion will stay in motion at constant velocity if no net force acts. And that friction would be a net force. That's Newton number 1, Isaac.
That's why slings work.
So you get pushed. Well, no, the car side pushes against you. Is that because it's accelerating?
Yeah. Yeah, the car's accelerating inwards. It's pushing against you. You feel the reaction force. You feel yourself pushing against the car. Other examples of circular motion. What about the moon? That goes around in a circular-ish path around the Earth. What provides the centripetal force?
Gravity.
Gravity provides the centripetal force.